Welcome to Web Handling. My name is Dave Royce, and I am super excited to continue our new series called Insular Industries. In this show, we will cover another of the oldest and largest of the web industries, textiles. If they can have web handling blind spots, pretty much anyone can. Topics covered include quality testing, winding, splices, selvedge edges, guiding, and tensioning. I know your time is precious, so let's get started. Textiles is the oldest, by far, of any of the web industries. They have had moving tensioned webs for about 2,000 years. They may also be the largest of the web industries, about $1 trillion globally every year. This makes textiles bigger than paper and plastics and metals combined. They may also have as many web machines as any. I have seen nearly 1,000 looms running under one roof. Yet, even so, textiles does not have it all figured out. They are in a cultural backwaters regarding certain QA testing, such as tensile strength, as well as winding and other areas. 500 years ago, Leonardo da Vinci invented the tensile strength test. Strip tensile is not only the standard amongst nearly every web industry, it is also standard among tensile testing of just about any material, web or otherwise. The glaring exception is textiles and some nonwoven that use grab tensiles. So what's the difference? The difference is small but vital. In the strip tensile, the grip is wider than the specimen. With the grab tensile, the grip is narrower than the specimen. So, why should such a small difference matter so much? Easy. Because strip tensils can be used to predict design parameters, such as sizing tension components, and to predict performance, such as web breaks. Grab tensile can do neither. So, how did textiles start off and continue down this odd path? I'm not sure, and I'm not sure anyone knows, because it began long before we were born. However, I was told that the narrow grip is supposed to somehow mimic the button and the whole attachment that some textiles have, even though it bears almost no geometrical resemblance. This legacy, once started, continued even though very few textile and nonwoven attachments are with buttons. Textiles are mostly attached via sewing, and nonwovens is usually attached via thermal or ultrasonic bonding. In any case, we do what our fathers did and what our fathers' fathers did and so on. I started my professional career more than 40 years ago as a designer of high-speed two-drum winders for the oldest and arguably most proficient of the web machine builders. Later, I became a manager of winding research. Later still, I wrote 2 books on winding, and I have a PhD thesis in winding. I have seen no less than 10,000 winders in my travels to 1,000 plants. Yet, in all of my travels, I have never been so shocked as to see how backward textile winders are. Perhaps the most glaring shortcoming is the lack of a rider roll on the top of the winding roll. In most industries, the pack roller is computer controlled to provide a precise nip load on the winding roll from the core to the outside. This land roller is standard nearly everywhere else except for rubbers and textiles. The outcome for not having this essential two-drum winding element is threefold. First, you may not even be able to start the wind. I have seen scores of textile looms that have had to use 50-pound or 25-kilogram weighted shafts to get enough nip to start the wind. Consider the ergonomic insult and safety hazard of requiring the operator to lift such a heavy shaft into the drum pocket. I have seen scores of rubber winders that would hop and skip and bounce on the drums as they tried to pull tension without sufficient nip. Second, you get looseness near the core, exactly opposite to the best practice teachings. That can result in telescoping and other defects in the next winding operation. Third, you get tight over loose, again exactly opposite to best practice teachings. That can result in starring in other collapse-related defects. There are many places where you can learn more about two-drum winding. Perhaps the best is my award-winning and trademark Web201 class that has been taken by 5,000 students. Written sources include my 2 books on winding, as well as 100 other publications. There are many other cultural handicaps found in textiles and sometimes nowhere else. One example is the manual splices that result in many feet, sometimes 100 feet of scrap because the splice is made so crooked. Also related to batch operations is the use of carts instead of wound rolls to serve as intermediate storage. These violate the first principle of manufacturing, and that is to not create disorder in the first place. The disorders I am talking about is the need to correct web flatness and position and tension that existed on the upstream process. This cultural handicap results in a nightmare amount of extra equipment that would not be present had they used wound rolls for intermediate storage, like almost everyone else in the world. Then there is the selvedge edge, which often wrecks the wound roll edges because it's thicker there. Then there are surface winding defects that might be avoided by using more sophisticated winder geometries, like the center surface winder. Then there are tension systems that are often undersized. Then there are guides that often don't. We saw that theme in both paper and metals. I could go on, but this list should be sufficient to illustrate that textiles has not availed themselves of solutions that have been known in other industries for decades. Thank you so very much for joining me in this Insular Industries mini-series. Please join me next week where we will continue our discussion of cultural handicaps by critiquing another of the mega industries, printing. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.